All right, example 4, determine the infinite limit. Again, infinite limit they're giving us here. Let me clear out all the stuff we had on the calculator. This time it's a sine graph. X plus 1 on top over x over sine of pi x on the bottom. And what usually creates infinity is 0 in the denominator. That's usually what creates it. And notice if we look at this function on the bottom, suppose I just try to put in the number 1. This would be 1, right? This would be sine of pi. What's sine of pi equal?
Sine of pi?
If we go back to our unit circle, pi lives right here, right? There's 0 right there. Cosine's negative 1. What sign?
0.
0. All right, so we got 1 times 0 is 0, so we got 0 in the denominator. If x equals 1, we're dividing by 0. Again, that's usually what creates infinity, it's division by 1. All right, we have to determine whether it's a positive infinity or negative infinity. I don't know about that yet. And it does say x is approaching 1 from the right, which means we want to pick numbers bigger than 1 and get smaller. So maybe 2 might be 2 or 1.5, something like that could be a starting point, and we're getting closer and closer to 1 from that direction. Typing this in, again, be careful with rational structures. X plus 1's on top. Make sure we put x plus 1 in parentheses. Hit divided by, and then I'm going to put parentheses on the bottom. I'm going to do x sine. Notice it begins with parentheses for sine, then I hit type in pi x. End parentheses for the end of the sine structure, end parentheses for the end of the division. Again, anytime you use sine, cosine, and tangent, especially when I'm taking physics, because physics is all about degrees and calculus is all about radians, I want to make sure I go to my mode here, make sure I'm in radians, not degrees, if I'm doing a sine or cosine or tangent. All right, once I established everything as it should be, I've got my equation typed in correctly, I go to my table. I'm going to pick, let's start at 1.5 in this one. And we want to get closer to 1.
1.9.
That'd be closer to 2.
1.1
would be closer to 1. And then maybe 1.01, 1.001, 1.0001. Yeah, there's no magic numbers, but just do that each time. Get really, really close. Keep adding zeros before the 1, or keep adding 9s if you come from the other direction. Typing in all these numbers, 1.5, 1.1, 1.001, 1.001, 1.0001. Alright, so we got negative 1.667, negative 6.718, negative 63.36, negative 636.3, negative 6,366. Again, we're getting so close to each other. Like these, again, if we look at this and did that strand of hair test, strand of hair wouldn't fit between these two values of x. We multiplied it out a little bit more than 10. It's 10 times bigger. So again, that's telling me that as I get incrementally close to 1, this answer is getting extremely large in a negative sense, so the answer would be negative infinity. And again, if the job is to determine a limit, that's your job. Numerically, just using a chart to figure out the answer, keep getting really, really, really close to this number and see what the y value is getting really, really close to. That's the answer to the limit. If it's getting to infinity or negative infinity, you identify that. If it's going to a specific number, you should identify that specific number. And those should, again, get really close to each other. You know, and you should be able to notice that from just doing this numerical technique.